Today I'm going to continue the homework question on force vibration. And then I'm going to go into an example on rigid body rotation about fixed axis. I'm going to do the same example as last Thursday because I have to admit, last Thursday, the last half an hour of lecture, I was shit, isn't it? It was so bad that when I watched the video, like, really, I could not even understand what I was talking about. Okay, so I'm going to go over the example. How many of you agree? Last Thursday, the last is shit, right? Thank you for your honesty. Okay, it is. Listen, when it's bad, say it's bad. Okay, when it's good, say it's good. Okay, as engineers, we have to have our point of view. Are we clear? Right? Not like when it's bad, you say it's good, and when it's good, you say it's fantastic. Are we clear? Okay. Right. I'm going to do this problem. I start it halfway, but I'm going to start from the very beginning. A 4-pound weight is attached to a spring, having a stiffness of 10 pounds per feet. The weight is drawn downwards at a distance of 4 inches and then released from rest. If the support moves with a vertical displacement of 0.5 sine 40 inch, where t is in seconds, determine the equation which describes the position of the weight as a function of time. Now, this is slightly different from what we get when I do the example in class. In the example in class, what is different is this is in terms of what? Force. Remember when I do the, but this question gives an example in terms of what? Displacement. Okay, so yeah, I also make the same mistake before. Okay, so you have to watch what is the value given. So once you sketch this out, okay, the first thing, okay, now we have spring. And then we have our mass. And then we have our displacement y. And this is under a displacement. And this is equal to 0.5 sine 40 inches. Okay. So the question asks us to describe the equation which determine the position of the weight as a function of time. Okay. So what we know so far, okay, we know that this is a undamped system. Okay, I like to highlight this because term test is next Friday, isn't it? Okay, and I want you all to be very sure that this is not equal to what? Does it look the same? From far, it looks the same. From near, it's not the same. Are we clear? Okay, when I was your age, I thought it was the same thing. Okay, I thought it was the same shit, different smell. It's not. Okay, the smell is far, far away. Are we clear? Okay, so undamped and underdamped are not the same because this is without a damper. Underdamped is with a what? With a damper. Are we clear? Okay, so we know that we have a general solution as in f as a function of time. This will be equal to C1, C1, right properly, C1 sine omega nt plus by C2 cos omega nt. And this will be plus, right? And we know the general form is F naught over K. That's what is in our what? in our notes, right? So this will be equal to 1 minus by omega naught over omega n squared. Okay. So do you want me to write some summary notes? Yes or no? Does that help? Or I can carry on solving. Okay. So the first thing you realize on your summary sheet, okay, that you can write this down when what? When it is a undamped system. Okay. Omega n is equal to square root what? A over m, right? And when it is a underdamped system, right? It's equal to what? It's equal to omega what? Omega d. Can you see that? So this will be equal to square root of 4mk minus by c squared divided by what? 2m. Okay. So and under them with a damper, we get what? Omega d. For this case, undamped system, we have what? Omega n. Okay, so I write some more things out. So if it is a underdamped system, okay, so I will. This is a summary sheet. Okay, I do apologize for. So when it's an underdamped system, all right, we have y as a function of time. This is equal to what? E minus alpha t bracket C1 cos omega what? Omega dt. Yes or no? Plus by what? C2 sine omega d what? T. Are we clear? There's a difference. Okay. So for undamped system, right? What disappear is the what? The alpha term. So we have C1 sine, or you can start with cos, does not matter. Okay, cos. Now this is equal to what? Omega n. Are we clear? Okay, so don't get confused for both. Okay. Right. So let's come back to our problem. As I said, the summary sheet is continuously what? Been what? Improved. So ideally, when you write your summary sheet is when after my lecture, you do some self-study, you start summarizing. Are we clear? Okay. If my lectures is 4 pages long, your summary sheet has to be how long? Half a page. Are we clear? You don't write, okay, Eugene say do summary sheet. His lecture is four pages. My summary sheet is what? 4 pages. What a waste of time. We clear? Okay, so it has to be half a page. Okay, but continuously what? Improving. Right, so from here, we know that F node, okay, in terms of units, right, F naught over K is equal to what? In terms of unit. So this is Newton divided by Newton per meter. So this is equal to what? Meter. Or in imperial, you have pound divided by pound per square feet. Over here, you have what? Feet. So what is meter and feet? This is in fact your what? Deflection, which correspond to, oh, sorry, displacement. Sorry, it's your what? Displacement. Amplitude. Yes. Inches is delta. Deflection or displacement. Okay. Yeah, you do. I will post the formula sheet 2 days before the term test. Okay, I will not expect you all to memorize everything, but you need to remember some things. Okay, right. So coming back from here, okay, with all this information, let's see what we can achieve, what we can obtain. Okay, so the first thing we need to know, we have to find what is our omega n. Omega n is equal to square root k over m, right? And we know that k is equal to what? 10 pounds per feet. Okay, and m is equal to, we don't know what is our mass equal to. Okay, so mass, okay, so the next thing, you go from weight, and then you have what? This is in your summary sheet. Okay, weight and what? Mass. Okay, so sorry, I need some space. So you, on one side you put weight, and on the other side you put mass. Okay, so in SI unit, 1 kilogram, 9.81 what? Newton. Hey, what am I doing? Sleeping. 9.81 Newton is equal to 1 kilogram. Okay, in imperial, okay, you have what? You have 1 pound. Is it 1 pound or, yeah, or 32.2 pounds is equal to what? Let's look. Okay, so now we are given the what? We are given the weight is equal to what? 4 pounds. So the mass is equal to 4 divided by what? 32.2. So 4 divided by 32.2 is equal to 124.22. I'll write down here. Okay, I have not enough space. So this is equal to 124.22. 4 times 10 to the power minus 3. So, okay, so therefore, okay, so this is an important value for you. Okay, so therefore, omega n is equal to square root 10 divided by what? 124.224 times 10 to the power minus 3. Okay. So 10 divided by 124.224 power minus 3. Square root of the whole thing is equal to 8.972. Okay, 8.972 radians per second. So another thing you can write down here, right? In terms of stiffness, right? SI unit, the thing to go for, the SI unit is in what? It's in Newton per meter. In imperial, okay, this thing will be in what? Pounds per feet. Okay, just to remind yourself, are we clear? So that should be on your summary sheet. So we know our omega n. Next, we know that our omega naught is equal to what? Omega naught is equal to 4 radians per second. Okay, so finally, you can write out the expression y as a function of time. This will be equal to C1 sine, right? Omega n, which is 8.972 t, plus by C2 cos 8.972 t, and then plus F naught over K, which is your displacement amplitude. So now this is equal to 0.5 divided by what? Divided by 12. Why you need to divide by 12 is because of what? over here is convert inches to what? To feet. We clear? Okay. Then this will be equal to sine. Okay. Omega naught is 4t, and then the whole thing divide by what? Divide by 1 minus by 0.4, which is 0.4 omega naught over omega n 8.972 on 8.972, and the whole thing we squared. Okay. So from here we were to compute C1 sine 8.972t plus by C2 cos 8.972t plus, so 0.4 divided by 8.972 square root, no, square root, squared, come on, answer squared, 1 minus, then you have 0.5 divided by 12 divided by